Hello, everyone. Yeah, it works perfect. So I'm Oliver. I'm CTO at Aleph Cloud, and today we're going to be talking about a new architecture for Aleph Cloud, soberly named Aleph v2. And the goal is to propose an architecture that can help us properly decentralize hyperscalers, such as AWS, and provide a better alternative to these monopolies. So first, a word of congratulations. Decentralization is over, as you've seen this week. The financial institutions are coming. Basically, we won. The game is over. This is the last ECC. Pack your bags and go home. Banks are taking over, and crypto is over. Of course, we know that this is not in fact true. This is just the beginning of the journey, and my point is to hammer that down because I think that we have a severe problem on our hands, actually. And that problem is named hyperscalers. That problem is named AI, because basically we see, well, finance was the first use case, but we're still depending very much on centralized infrastructure. Most DeFi protocols are still hosting their front ends and back ends on AWS, Azure, or Google Cloud. And you see that basically these guys are holding us pretty much hostage in a number of ways. We have a $1 trillion industry today that is managed by 3 major players that are all US based. This is a major problem for sovereignty for all non-American users. I'd argue that it could be a problem for Americans too. And we basically know that these 3 players have a bad history of vendor lock-in, data misappropriations, censorship, and basically it's only going to get worse. Because we see that AI today, we have the likes of OpenAI and Anthropic. So I don't know in the room who trusts OpenAI and Anthropic with their data. If you could raise your hands. Yeah, exactly. You're held hostage. And so basically that's a problem. These guys could become the biggest monopolies ever. And we have to, well, we know the lessons. We've seen this happen before. So maybe this time we have the technology and the necessary tools to avoid it or to at least provide an alternative. And basically, it's a very simple thesis. I think the world needs an open hyperscaler. So you might ask, well, doesn't blockchain already solve this? And for a number of reasons, the answer to that is no. Blockchain solves very specific problems, which are, great. Blockchain does this amazingly, but it's expensive and limited in the forms of compute that you can do. You need specific languages to program these things. You also, well, until very recently, had no privacy. And also, well, no networking, no I/O, no way to get access to most of the data. So you either needed off-chain systems or oracles that brought you the data on-chain. Either way, this is not appropriate for general-purpose compute. This is a problem that will take time to be solved on the blockchain level. I think some people are scaling the blockchain, the things that you can do on the blockchain. And that's great, but we take the opposite approach and say, well, how can we come from a centralized system and decentralize it? We know that if you want maximum decentralization and absolute resilience of your financial applications, again, blockchain is a way. I think we needed something in the middle. Main problem today, so this is not a new problem, of course. This is something that was attempted to be solved back from the 2017 ICO period. But I would argue that most decentralized cloud today absolutely suck. And ours too. Compared to hyperscalers, basically you have these guys who have had the most proficient professionals in tech work for them to develop these things for the last 20 years. And so as a result, they're extremely convenient, extremely scalable. They provide high availability across the board. Well, you do have a few incidents thanks to AI these days. That's great for our marketing. But overall, these guys are good at what they do. And that's the main challenge here, because you could argue that banks in the past were not so good at what they did. These guys are killers. And so that's one of the biggest problems that we face. On the other hand, when you look at existing decentralized clouds, they scale pretty poorly. In terms of fault tolerance, there's not that much fault tolerance at all, besides the payment layer, because that part is on-chain. But the rest, if you rent a VM, typically on most of these services, if the node that hosts this VM goes down, the VM goes down with it, and there is pretty much little recourse to you have towards that. It's a main problem. You have obvious network speed limitations because these things tend to ignore actual network topologies. You usually have, well, no managed services at all, and God knows that enterprise loves managed services. And we either way, also these networks either focus on one part of the problem, which is either compute or storage, but they never provide both at the same time. And yeah, the goal is to change that. I want to clear some misconceptions as well, because some people are arguing or thriving on these arguments. I think they're wrong. The first being that decentralized cloud networks can be much cheaper than hyperscalers. So hyperscalers do have healthy margins. That is absolutely true. But the way current decentralized clouds are implemented today is usually involves a lot of intermediaries to provide nodes to the network. So if you want to actually compete with hyperscalers, you need to be talking to the data centers directly, to the professionals who host the hardware, because otherwise you just add, intermediaries that you need to pay in the middle. It is very complicated to compete on cost otherwise. Another problem as well is that those will argue that residential nodes provide great, edge computing for everyone. That's just ignoring that's not the internet is configured today. Usually, most traffic between residential blocks will go through your ISP again, and so basically, the data center topologically is much closer to your ISP than the next block could be. And so, overall, one argument that I want to make here is that we need to keep it decentralized, but work closely with data center operators, because these guys are the professionals that are working to get the performant hardware, manage to make economies of scale, which is very important here as well, and also know how to manage great uptime for all the workloads here. Thankfully, we have an edge here as well in decentralized compute. Is that my point for decentralization here is that this solves a very real problem that we have in decentralized cloud computing actually, is that data centers are critical infrastructure, and we see that they are being targeted more and more, or sometimes not targeted, but just have incidents. And basically this is gonna be clearer and clearer that these things are targets, military targets, and are not defended, at least at the right level of defense for these such critical infrastructure. And I believe that here decentralization can play a key role in providing resilience by default for most compute workloads. And so this is a thing that's actually a great selling point for enterprise. So before we jump to the architecture, just wanted to talk about the key properties that we envision here for Aleph v2. So one thing that I really want to insist, because some people will tell you, no, decentralization doesn't matter, you should focus on users, PMF, whatever. I think in this case, decentralization is actually a core value and a key feature that we can sell to users. It's just not named decentralization in the real world. It's named multi-cloud, it's named resilience. It's basically providing failovers for your user applications. And that's very valuable because you have entire DevOps teams at most enterprises focusing a lot of time in making sure that they have redundancy between different cloud providers, different data centers. And this is actually a major DevOps cost for a lot of enterprises. Also, for the reasons I mentioned, we want to have most nodes still in data centers, but that doesn't mean that it's not decentralized. It just means that it's decentralized at the data center level, so that you are cross-data center there. And we want decentralization for the payment level as well, because we want on-chain payments. That is very useful because it enables a few use cases like agents paying for their own hardware, which is one thing that we developed recently. In terms of trust assumptions, so of course there are going to be a few trust assumptions here. What we want to do is that the worst that an attacker can do is censor. We don't want any way to meddle with anyone's workloads or storage. So we want integrity at every step. The way we do that today is by relying on TEEs. There is a big debate about ZK, FHE, and TEEs in crypto. I do believe for what we're doing today at the scale that we're envisioning, TEEs are the only way that works. But this comes with two very important trust assumptions. One, that we have to trust Intel and AMD because these guys have the keys. And the second thing is that we have to deal with the recent TE vulnerabilities, so hardware attacks. And so our secure model should try to avoid these pitfalls as much as possible. And finally, in terms of UX, one conclusion here is that regular people absolutely hate the crypto UX. So you want no apparent wallet, you would just want regular accounts, you don't want to pay gas fees. So you need to avoid that. Thankfully, recent developments on the blockchain level allow you to avoid that. So yeah, let's talk architecture. And now, first, before we jump into the architecture of v2, I want to talk about the AWS architecture. And this is a simple diagram that shows basically the minimum components that you need to make a thing like AWS tick. So when you have a user making requests, essentially what happens to reach an application on Amazon, first you need a DNS to tell you where you need to access your the AWS domain. This typically points you to a CDN, so this is called CloudFront in the AWS domain. This thing essentially is a regional local cache that can get you data faster if it's available. It can also do local compute and a bunch of other things, but that's basically as close as you get. Typically, what's going to happen is that, well, it caches or does a bit of as many things as possible close to you, but for a lot of requests, it will still have to defer to where your application actually lives. So this arrow there does a lot of heavy lifting because there can be thousands of kilometers that are covered by this. And basically here you have your whole region that is where your whole regional deployment, and that comes with a gateway that tells you where your application lives, so that knows exactly on which servers inside the Amazon data centers where your VMs are running, where your storage is located, how to access all that that matters to your application. And inside that domain, in green, you're going to have compute. In purple, you're going to have storage. Basically, what matters here is that behind the scenes, you have these components that are critical as well to this infrastructure. You have some form of scheduling where you need to know how which server to pick to run specific workloads. This basically selects a node and selects and ties the VMs to for specific nodes. You have IAM, which is their access control system. This is essential as well because you need to be able to protect your infrastructure, make sure that you have fine-grained permissions on who can do what. And you finally have your key management system, which enables you to store secrets and make these secrets available to your workloads. So these are, I would say, the basic building blocks that we need. All or most, at least, AWS applications are built on top of this. So my theory here is that if you manage to build a decentralized version of this, this enables a ton of higher level managed services that can be built on top of managed infrastructure, managed decentralized infrastructure. And that's a goal here, to minimize the number of core building blocks and decentralize that. So this is the architecture we propose here. So how does it work in terms of user requests? So similar to, one thing I mentioned here, I will not cover the DNS and CDN parts here because this is, there are complications for these things to decentralize these because you need to find the hardware in the right places. You need to, get this. I think this is something that we'll solve once we get this at scale. So first here, in terms of gateways, so user goes through gateways. We provide decentralized gateways. I'll explain what it means later. These gateways know where your application resides, know on which compute nodes they should go, know on which storage nodes your data is, and essentially provide you routing to specific applications. Then inside this, you have all your compute and storage nodes. Here you will see that I mentioned TEEs for all compute nodes, very redundantly. The goal is to say that we use TEEs aggressively to guarantee verifiability and integrity. And this is what enables the trust property that what the worst that these guys can do is censor, because, well, if a gateway goes down or censors a specific application, it just, one of the gateways will censor you, but you can still access your workloads through other gateways. How is this all placed? Well, you basically have a set of nodes on the top, which is what we call the schedulers. The schedulers act in consensus and basically decide how to tie your VMs to specific compute nodes. They monitor VMs so that they can detect downtime and they can detect malicious nodes. And the idea here is that essentially this consortium of schedulers will take decisions, will migrate VMs as necessary, and so on and so on. And finally, for all the global state, so that we use blockchains here, but we store essentially everything that's global, and I would say slow state on-chain. The idea here is that you can also do, your node staking, your declaration of user resources, your payments, fully on-chain here, and have these properties be read by all these nodes that are here regional. So yeah, what I failed to mention here was that this is one single region. For example, here, this example is in Western Europe. And we expect to have regions like this all across the world. So now let's talk about each component individually. I'll be very quick because I don't think we have much time. Schedulers essentially are a set of nodes in consensus. They have a rotating leader. The idea is simply that they will monitor the state of the nodes, and we know which node is up, and basically accept or reject the scheduling decisions based on that. You basically have few schedulers per region because, we don't want to multiply that. We want to have as little overhead as we want. I propose a number of 10 at the moment because that enables for 3 nodes to be malicious and still function. So I think this is overall a decent assumption, but happy to discuss. And well, these things, as I mentioned, these are where VMs execute, monitor the lifecycle, and migrate them away from unresponsive nodes. This is pretty important. So migrations, one small word on that is that not every application can be migrated fully. So this will be up to the user to tell its requirements to the system to say, well, this can be migrated automatically. This needs storage. This needs, this relies on specific features, and essentially the scaling system will be able to act accordingly. Okay, gateways. Gateways, on the other hand, are how we handle migrations stresslessly. We just have IPv6 routers that guide through our application. They have a common IPv6 prefix that they shard per VM. Each VM gets an IPv6 subnet. And essentially, across migrations, this IPv6 subnet is fixed. So for you as an application user, this doesn't change anything if your VM migrates. You might have a bit of downtime for specific use cases, but that's it. Also, what those things do is load balancing, auto-scaling as well for Lambda functions. So the idea here is to support Lambda functions as well. And well, what we do is that we have multiple gateways in the same model as RPC nodes for blockchains here to avoid censorship. Quick word on storage. I don't think we invent much new on the storage level. The goal is to reuse the state of the art here, meaning, in general, a system where you have storage coordinators that manage a large set of storage nodes. These storage coordinators essentially track shards of your data, so everything is erasure coded. They also monitor bandwidth usage and report that back for your system. This obviously needs caches in front of it for fast access from your user domains. As mentioned, we'll talk about CDNs in another presentation. But yeah, basically this enables reliable storage here because you have auto repair mechanisms, you have automatic audits of nodes to make sure that your data is still there. This is nothing new, but using the state of the art of what exists. And yep, here we go. Finally, on key management system, here again, nothing new with TEEs. What you want to avoid essentially is to avoid storing long-lived secrets on a single TEE-backed machine. So what you want to do is use every trick in the book to avoid doing that. The one typical trick is MPC, where you shard your secrets and you issue maybe session keys to your nodes, or you can also have system where you have for specific operations where you need voting systems, and so on and so on. But basically, the trick is really to avoid giving all the keys to TE-backed applications because of the hardware vulnerabilities that we know, and that will certainly evolve. I'm sure we'll discover more in time. But yeah, this is the goal is to avoid this. Here we go. And finally, on payments, very fast. This is as well state-of-the-art on-chain payment systems. You want account abstraction for your users to sign in any way whatsoever. You want paymasters to avoid gas fees. This is very standard. We want on-ramps for credit card payments. This is all things that exist now that have existed for the last few years. And then finally, what we'll do on-chain is that we split some level of user assets, but basically all the high-level user assets will be declared on-chain. Okay, so conclusion. Essentially, we provide a system that's multi-cloud by default, with a standard cloud UX, which is something that's relatively new for decentralized clouds, with fully on-chain payments. The idea here is that we provide something that is sufficiently decentralized to resist most data center incidents. On the other hand, what we do have is that if you want maximal decentralization, please by all means go use blockchains. This is what they are for. They have their own set of pitfalls, but if you are ready to accept them, go for it. And also, well, we are very well aware that we use TEEs, so attack us for that, no problem. This is a part of the problem. But yeah, thanks a lot for your attention.